In this video, we will discuss solving the dot product of any two vectors. If you multiply a scalar number by itself, you get the square of that number's magnitude. It is useful to have a similar operation for vectors, where if you multiply a vector A by itself, you get back the square of the vector's magnitude. This would be the same as simply multiplying the magnitude of the vector with itself, and as such, the answer we get back is, in fact, a scalar, not a vector. This operation is called dot product or scalar product. This operation can be extended to any two vectors. To dot together two different vectors, it is easiest to imagine the vectors starting from the same point. Since the dot product concerns vectors pointing in the same direction, we first need to project one vector onto the other. The projection of A onto B is A sub B, and the dot product of A and B will then be the magnitude of A sub B multiplied by the magnitude of B. Notice that A sub B is just the magnitude of A times the cosine of the angle between the two vectors. So A dot B will be the magnitude of A times the magnitude of B times the cosine of the angle between them. It does not matter if we project A onto B or B onto A. So A dot B is the same as B dot A. Notice that if two vectors are perpendicular to each other, their dot product will always be 0. Which leads to some general statements that can be made about the dot products for our unit vectors. Any two unique unit vectors dotted together must be equal to 0, and any unit vector dotted with itself must be equal to 1. Some vector r, which can be expressed in terms of its components r sub x and r sub y, can then be projected onto the I and j axes by dotting r with I or r with j. I dot r will be I dot the sum of r sub x times I hat plus r sub y times j hat. Because I dot j will go to 0, we're left with only r sub x, which can be rewritten as r times the cosine of theta. The same procedure can be done with j dot r. J dot I will go to 0, leaving us only with r sub y. Therefore, j dot r will be r times the sine of theta. If you already know the vectors in terms of their components, the operation is even easier. You can either use tangents to solve for the angle between the two vectors, then use Pythagorean's theorem to solve for the magnitudes, and plug the numbers into the equation above. An easier method is to use the projections of both A and B onto the coordinate axis. Vector A is just A sub I plus A sub j plus A sub k. B is B sub I plus B sub j plus B sub k. When these terms are multiplied together, only the products that have the same unit vector will survive. So A dot B becomes A sub I, B sub I, plus A sub j, B sub j, plus A sub k, B sub k, turning the problem into simple arithmetic. And there you have two easy ways to multiply together any two vectors.